also known as the law of inertia, states that an object at rest will stay at rest and an object in motion will stay in motion unless acted by an external force. When the pen is resting on the table, it stays still due to inertia. It requires an external force like accidentally bumping the table or in this case, Maisel knocking it off to overcome that inertia and cause it to move. Once the pen slips off the table, it continues to fall until another force, such as the ground or air resistance, acts on it and brings it to a stop. This shows how objects resist to changes to their motion, a key aspect of inertia. As the law of inertia states, before you pull the chair, it's stationary, meaning it will stay still unless you apply a force to move it. In this case, the force is the pull you exert on the chair to slide into position. The chair, due to its inertia, resists these changes in motion. Now, for our second law, the law of acceleration. This law states that the force is directly proportional to acceleration, but acceleration is inversely proportional to mass. In this instance, Cariel is about to throw a paper to get the attention of Maisel. Now the force applied by Cariel to throw the paper is equal to its acceleration. Although the paper thrown was light, the force applied was minimal in order for the paper to travel longer. The light paper was not enough to get Maisel's attention. Cariel tried a more weighted paper and exerted more force than the lighter paper in order to travel faster and longer. She has now Maisel's attention. Lastly, the law of action and reaction. An object exerts a force on another object and the second object will apply the same force but in an opposite direction. For every action, there is an equal but opposite reaction. Here we have Krisha, about to take a seat in the library. Sitting down is one of the famous examples of this law. The force applied by Krisha sitting down is also the same force exerted by the chair but opposite direction.